Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I am Sofia Karima from Center of Technology for Maritime Industrial Engineering, the agency for the assessment and application of technology. I would like to present our latest study about a numerical study of submarine landslide generated tsunami and its propagation in Mamuju, West Sulawesi. The background of the study is motivated by a catastrophic earthquake event with magnitude of 6.2 that occurred at 15 January 2021 at Majene, West Sulawesi. As we can see in this picture, the star shape was the location of where the epicenter of earthquake occurred. This event caused 84 fatalities, hundreds fatal injured, and thousands people evacuated, according to BNPB 2021. At that time, BMKG also made a press release, and they state that there is a potential tsunami landslide in those areas because of the earthquakes, and this issue become our fundamental background to analyze and study the tsunami landslide simulation in West Sulawesi. According to a previous study related to the tsunami landslide of tsunami could generate a very large run-up heights, but it has limited far-field access compared to earthquake tsunami. The main area for our study is shown in pink box in the left picture, and then we move to the other figures. The red box is where the source landslide is located. And in this study, we use two different models. The first one is NHWAVE or hydrostatic wave model for wave generation, and the latter we will use fan wave model or fully nonlinear Boussinesq wave model for wave propagation. Here is the observation point that we will analyze from point 1 to 42. This is the data that we use for NHWAVE simulation. The bathymetry we obtained from BATNAS or Bathymetry Nasional, and the grid size is 300 meters, both columns and rows, and the slide angle is 200 degree. The slope angle is 15 degree, and the total time for NHWAVE simulation is 1 hour with the time step 1 minute or 60 seconds. And we use three different scenarios for NHWAVE simulation. The first one is a scenario with 0.5 kilometer of landslide volume, and the second one is 0.8 kilometer cubics of landslide volume, and the latest one is the largest, which is 1 kilometer cubic. The length, the width, and the thickness of landslide, the length, the width, the slope, and the slide angle for all scenarios are the same except for its thickness. After we do NHWAVE modeling simulation, the next one is we also simulate the tsunami propagation with the fan wave model, and here is the domain that we use for fan wave simulation model. It is larger than the domain that we use in NHWAVE simulation because we want to see its propagation, so it requires a larger area. And the data that we use, the first one is the bathymetry. It is still the same as NHWAVE simulation. We obtain it from Bathymetry Nasional, but the total simulation time is different. In this fan wave modeling, the time simulation that we use is 3 hours with time step 1 minute, and we also use the output file of NHWAVE. The velocity and the elevation to be the input for this modeling. The purpose of fan wave model is to analyze the tsunami wave propagation using the tsunami source that obtained previously from NHWave simulation. This picture shows the result of NHWave simulation for three scenarios. It is seen that the larger volume of landslide will create the greater distance of a tsunami wave. It is seen that if the landslide volume is 0.5 km cubic, then the maximum distance would be approximately 18 km. And if the landslide volume is 0.8 km, the maximum distance would be 22.5 km. And if we use the largest scenario, the largest landslide volume, which is 1 km cubic, then the maximum distance is larger than any other scenario, approximately at 25.5 km. In the right graph, we also obtain the time series elevation in 5 different cities that located near the source. But as we see, there is only two districts affected by the tsunami. The first one is Deking, the second graph, and also Mamuju, but Mamuju in a very small value of elevation. From the NHWave simulation, we can obtain the maximum tsunami elevation for each observation point, and this figure shows each observation point that we will analyze, and this table shows the location of each point. This graphic is the maximum tsunami source elevation at every observation point, and it is seen that the three scenarios have relatively the same pattern, but with different height of elevation. The location that hit by the highest tsunami elevation is the same for three scenarios, which is located in number 18 to 20. It is highlighted in red box and also in this orange table. For the landslide volume of 0.5 km cubic, it reached maximum elevation of 0.4, and for 0.8 landslide volume, they reached the maximum elevation of 1 meter, and the largest landslide volume, hit almost approximately 1.2 meter at Majene. For fan wave simulation modeling, we use the worst scenario that affected the largest distance, which is 1 kilometer of submarine landslide. And this figure shows the wave tsunami propagation that started from the source. This is the location of the source that we already obtained from NHWave simulation. And the next figure is the snapshot of tsunami propagation after 45 minutes, 19 minutes, 135 minutes, and 180 minutes with the volume of 1 km cubic. We can see that the first location that affected by the tsunami is the West Sulawesi, because it is located near the landslide source, and after 19 minutes it reached this area of Sulawesi, and after 118 minutes the tsunami propagates through to all the area of Makassar Strait. It also affected to Kalimantan Island. So here is the conclusion of our study. The first one, three different scenarios with three different volumes were conducted as the input for tsunami simulation. The first simulation that we used was an wave simulation to generate the initial wave from landslide source. It is observed that different volume shows different affected areas, and the larger volume will affect the larger area. And the highest tsunami elevation for 1 kilometer cubic landslide volume is 1.2 meter, while for 0.8 kilometer cubic and 0.5 kilometer cubic landslide volume is 1 meter and 0.4 meter respectively. For those three scenarios located at Talapang subdistrict Majene, and the maximum distance of the 0.5 kilometer cubic volume landslide volume is 18 kilometer approximately. Meanwhile, the maximum distance of 0.8 kilometer cubic and 1 kilometer cubic are 22.5 and 25.5 kilometer. The fun wave simulation result is the tsunami wave propagation for 118 minutes later, and in the 118 minutes, the tsunami wave was still propagating towards the north of Sulawesi Island and to the east of Kalimantan Island. That's all my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.